Yeah, so thanks everyone for attending this talk. And building service applications on Azure, something I'm very passionate about, and I've been doing it for a lot of years. But one of the key things that Darren also mentioned is I'd like to help the community as well. So when Darren invited me to give a session on this for Codementor, I said yes very quickly because I think it's a nice opportunity for you to learn something new. And usually when I prepare these kind of sessions, I also learn something new. So it's good both ways. So it was already mentioned, but my name is Marc Duiker. I work for Ably, where we enable developers to create live and collaborative experiences such as chat or games or real-time dashboards. It's a really fun job. I can create nice content and blogs and vlogs. So I'm really happy with that. And it was also mentioned that I'm an Azure MVP for the last couple of years, mostly for my contributions to the serverless community. But let's get to the business of today. So I'm going to talk about serverless first in general, then about Azure Functions in specific. What is it? How can you use it? And then most of the time we'll be actually building Azure Functions, and you can even join if you want to. Finally, once we have built the function, we're actually going to ship it, deploy it to Azure. So you can even see it running in the cloud. And that's it. So let's start with the serverless. So what is serverless? So serverless is maybe a bad term, right? Because there are still servers used somewhere. It's sometimes also referred to as functions as a service, which I think is a better term, because what you actually want is you want to execute a bit of code, a function, and you want to have that hosted by some kind of cloud provider. So you're paying for a service by a cloud provider. So you're not managing the majority of that cloud resource. And so that's all taken care of by the cloud provider, in this case Azure. They make sure everything is patched security-wise. They just offer you to upload your code, and that should be working straight out of the box. Of course, there is some configuration that you can do if you want a bit more control, but mostly it's managed for you by your cloud provider. Serverless is more than just functions as a service, though, because there are also other services, like there are databases which are serverless, and there's AI services as well, which are considered serverless. So, but yeah, when people talk about serverless, they mostly mean functions as a service, so the compute part. But there's much more than that. So what's important for functions as a service for the compute part? Well, it allows you to really focus on the code, on the business problem you're trying to create something, to work out a solution for some kind of a problem that you have, and you can focus really on the code. You don't have to worry about managing where that code will be running, or how to operate it, or how to keep it up to date. Serverless is event driven, meaning it reacts on something. So you make an HTTP request to your function, and then your function executes, or a message is put on a queue, and then your function executes, or a blob file is written to storage, and then your function executes. So it's very much event driven, and sometimes you need to rethink a bit on how you create your whole architecture in an event driven way, instead of more of a command-driven way. Serverless also means auto-scaling. So when there are just a few requests, so let's say only one person visits your website, then only one instance needs to be active, and that is handled very quickly. But when 1 million people visit your website, well, then you need more functions, and then those serverless functions need to scale very quickly. And that's all taken care of for you automatically. You don't have to configure that or do something for it. That's all taken care of. Another important aspect of serverless is that it's pay as you go. So you don't pay a fixed price per month. No, you pay per function execution, and you pay per consumption of the gigabytes of memory that you consume when you execute the function. And it's usually a combination of those two. So that means if nobody visits your website, you're also not paying for anything, which is great, right? So you can actually start out really easily with a small proof of concept, and if you're the only one using it while developing it, well, you just pay a few cents. But if it's really successful and millions of people are using it, well, of course, then you pay also more because more people are using it. But you should incorporate that in your business model, right? Because people are hopefully then paying for it. Right, so these are important aspects of what serverless is. A very important part about the scalability, and so it really depends if serverless is useful for you. It depends on your workload. So if you have a workload on the right, which is very, very constant, then serverless might not be the best for you unless that very constant workload is very low. So that means you're hardly paying anything. But if it's very high, very constant, that means you always need a certain number of instances of your compute resource, and then you might be better off actually paying a fixed amount per month. When your workload is spiky, so it goes up from very low to maybe very high during lunch, because maybe you're ordering food and you have a food app, and then it's low again, and then around dinner time it spikes again. Well, this is more like an indication that this kind of workload is very suitable for serverless, because when their workload is very low, almost no instances are running. When the demand is very high, a lot of instances are then spinned up for you, and your code is executing with dozens or hundreds of machines, and then it goes back down and back up again. So serverless is ideal for a spiky workload. If you look at modern architectures these days, and more specifically event-driven and serverless architectures, we see something like this. So we see very small pieces of compute. So in this case, we're talking about Azure Functions, and then the resource is a function app. So we see lots of different function apps, which are usually good at just doing one thing. So it's not like a big monolith that has lots of responsibility. No, there are small function apps. They do just one thing. They process something. Probably they put something on the queue, and that triggers yet another function app, and some data gets stored or read. But it's dozens and dozens of function apps instead of one big monolithic application that does everything. And why do we prefer this over the monolithic approach? Well, let's say these three streams, so these three colored boxes and queues and storages are like three different functions of your web application. Let's say something happens with that middle stream. So if something breaks down on that middle stream, the first stream, the orange stream, and the white stream can just continue to operate as normal. Right, so your whole entire application is more resilient if you go this serverless event-driven way. So resiliency, but also scalability are two major factors why this architecture works these days. So now let's move to Azure Functions, which is one of the serverless services in Azure. There are more services, but this is the one that's probably the most popular right now. There's also logic apps, which gives you more like a UI where you can just click and drag boxes to connect the workflow. So there are some other things, but Azure Functions is, I think, the biggest one in Azure. So let's talk a bit about the anatomy of a function and a function app. So your function contains code. So it's a small snippet of code to validate some user input and to put something in a database. Your code is event-driven, so functions are event-driven. So your function has a trigger, and it always needs a trigger. So we'll always have one. I'll be showing HTTP triggers later, so that's the most used and often the easiest to get started with. But there are also other triggers like queue triggers and service bus triggers and blob triggers. Also timer triggers if you want to do stuff on interval. So your function always has a trigger. Next to the trigger, though, you can have an optional input attribute as well. And so in case we have an HTTP trigger, but we want to read something from blob storage, we can put in just one line of code saying, okay, whenever this HTTP trigger is fired, I also want to read a blob file from storage. It also has optional output bindings as well, which again makes it very easy to store something in storage, for instance, or put another message on a queue. So this is really, I think, the power of Azure Functions, that you have this very easy integrations with other services within Azure and even outside of Azure. I think there's also, for instance, a Twilio integration, so you can easily send a message via Twilio once you do a trigger of your function. So I think the biggest benefit of using Azure Functions is the easiness of integration with other Azure services using these input and output bindings. but today we will mostly be focusing on the triggers and more specifically on the HTTP trigger. So your function is part of a function app in Azure. So a function app can contain one to many different functions. So this is quite different how, for instance, it's done in AWS with Lambdas, because there you just deploy one function and that's it. But here the unit of deployment, so the Azure resource is the function app, and that app can contain many functions. That will also be in the demo later. So it's nice that you can group functions together in a function app. It can also be a bit dangerous, right? Because you can add like dozens or hundreds of functions within a function app. And what you're doing then is you're building a, let's say, a serverless monolith. So you should also not be doing that. Only add functions to your function app, which makes sense that they belong together. On the function app level, you also have application settings. These can include connection strings or API keys that you need to connect to other services. All right, so now let's get our hands dirty and start building it. I'll be using a lesson from Azure Functions University, and you can even join me now and go to this user URL. So bit.ly/az-func-uni. This is the full URL where we'll go to. I'll pause the slides right here. So this is the GitHub repo. Let me enlarge it a bit. This is the Azure Functions University repo. And if you scroll down a bit, there's a table with all of the lessons. And we are going to do the HTTP trigger lesson. And well, I'm going to do it in .NET 6. I mean, if you feel better by doing it in .NET Core or doing it in TypeScript or doing it in PowerShell or Python, feel free to do so. But I'm going to do it in .NET 6. So just click on the tick, and that will bring you to the lesson about HTTP triggered functions. So, and the goal is just to create our first function app, HTTP triggered in a .NET 6 isolated process. I will get back what isolated process means. And that allows us to do a get or a post to an endpoint, and it will return some information to us. So these are the exercises that we're going to do. So we'll first be creating just the template function app and just see if it's running out of the box. And then we're going to change that template function app a bit. And then we're going to slightly change it a bit more to change the output a bit as well, and how to handle just get request and how to handle post request, and also how to change the route of these HTTP triggered function. So if you haven't done any .NET development, then you probably need to install some additional tooling. So I will show the prerequisites page as well. So since we're working in .NET 6 today, you need the .NET 6 SDK. So you do need to install that. I'll be working with VS Code. It's my favorite editor for quite a while. So I'll be using that. The main benefit of VS Code is that I like the extensibility. So I'll be using lots of different extensions. For instance, there's an Azure Functions extension that I'll be using VS Code, which makes it very easy to create new functions. Once you have that Azure Functions extension installed, a dependency of that is also the Azure Functions core tools. And that allows you to develop and even run functions locally. So that's one of the benefits of developing Azure Functions. You don't need the cloud to actually develop and test your functions. You can just create them locally. You can run them using this core tools, which provides a local runtime. So you can easily test and debug them locally. Since we're making HTTP triggered functions, it's useful if you have a REST client, so you can invoke the endpoints that we're building. So I'm using the REST client for VS Code, but maybe you're more familiar with Postman, maybe you already have that. So either way, you need some kind of REST client. And that's all we need. The other things are the requirements for other lessons, which involves storage. All right. So let me now move this to one side and have VS Code on the other side. Okay. All right, so what I have here is VS Code, and I've created a folder called Codementor, and that's it. So I have an empty folder opened in VS Code. So what I'm going to do now is I'm going to use the Azure Functions extension. I'm going to run this command from the command palette. Azure Functions create new project. So Control Shift B or Command Shift B. Let's get rid of this message. And I already recently used it. So it's Azure Functions create new project. So let's use that. It first will ask you where I want to create this project. And you can put it straight in the folder I've opened. So I can just click this Codementor folder, that's fine. Then you need to select the language. Well, I'm mostly proficient in C#, so I'm going to choose C#. You then need to select the .NET runtime. This is a bit tricky because this is showing some of the older runtimes. So it's .NET Core 3 and .NET 5. But I want to create functions in, let's say, the latest long-term support runtime, and that's .NET 6. So I first have to change the Azure Functions version. So I change it to Azure Functions v4, so that's the latest version. And then I have two options for .NET 6. So the first one is just .NET 6. And if I choose that, then my function app will be in .NET 6, but it will share the same runtime as the Azure function itself, which most of the time it's probably fine. But if you want a bit more control over the dependencies of your Azure function code and how you want to do a dependency injection and things like that, if you need some more control over that, then it's better to create a .NET 6 in an isolated process. So that's the one I'm going to use, because eventually this will be the way to go for Azure functions, because it allows a bit more control over your code. So I'm going to change it to .NET 6 isolated LTS. Then the next question is, what kind of trigger are you going to make? So there are lots of triggers, but we're going to stay with the HTTP trigger for now, because it's easiest to build and test locally. Then we have to provide a name. So I'm going to change it to the name that's given in documentation. So that's hello world trigger. And then a namespace. And yeah, if you're not familiar with .NET, your code is usually categorized in namespaces. So in this case, I'll be using the namespace again from the documentation. So azfuncunit.http. It can be anything what you want. It's just a means to categorize or group your code. Then the final question, it's quite a lot of steps, but the final step is to choose the access rights. If you're just doing stuff locally, then it doesn't really matter which access rights you choose, because this has no effect when you run your functions locally. However, as soon as you deploy it, then it's a big difference. So if you want your function app to be accessible by anyone without any restrictions, then you can choose anonymous. But be careful, right? I mean, if the endpoint is available for everyone can call it. So that means if someone sees it and does runs it, let's say, millions and millions of times, then you will also be paying for all those millions of function executions. So always be careful about the anonymous access rights. What a good default is the function access right. So that means once it's deployed and you want to call this Azure functions via HTTP endpoint, you need to supply either a header or a query string with a certain function key in there. So let's do that. Okay, so we now see that it's creating the new project, it's creating the trigger file now, and here is our scaffolded project. So let's go a bit over the files. Shall I zoom in one bit more? Maybe it's a bit easier for people to follow. All right. So the thing what is selected now is our the class that contains our function. So it's just any regular public .NET class. It has a constructor that accepts an iLogger factory that's automatically injected by the Azure Functions runtime, so you don't have to worry about it. So if you want to log something, you can use this logger. And here is then smaller. Here is then our function definition. And functions are recognized by this function attribute. The function itself is just a public method. And since it's an HTTP method, the return value is of HTTP response data, and the input type is HTTP request data. The thing in the middle here, let me put this on a new line. So this is the HTTP trigger attribute. So this is recognized by the Azure Functions runtime that this is a function of type HTTP. Here we see the authorization level. So it's now decided that this can only be called if it's deployed, if you provide a function key, and it's allowed to either do a GET request or a POST request to it. So what does this default function do? Well, it logs some bit of information in here. Then it creates a response, and it creates a response based on the request. And then there's a method called create response, and we provide an HTTP status code back. So in this case, we receive a 200 OK back. We assign the headers to be of content type plain text, and then we write a string to the response. Welcome to Azure Functions, and that's it. Then we return the response. So let's see if this is working. Well, first things first, let's see if we can build this. So if I do Ctrl+Shift+B, then this project will be built. So it's now building. Make the screencast mode so you can see what kind of keys I'm hitting. Okay, so the function builds without any issues, so that's good. So if you also have that, it means you have installed all of the right things. So now I want to run it, and I'll come back to the other files later. But if you created this via VS Code, you should just be able to hit F5, and that should start up the Azure Functions core tool. So it starts up the local Azure Functions runtime. Then we should see here that it's building again, and yeah, now it's starting the local functions runtime. And here we see that it's recognized that there is an hello world HTTP trigger. We can use either a GET or a POST, and this is the endpoint. And now it's ready for us to actually call that endpoint. So how can we call this endpoint now? Well, I already told you need a REST client. I'd like the REST client in VS Code. And how does it work? If I create a file here, ends with HTTP or REST. So I can now do get, and then I copy paste this link in here. Right. So because I have installed this REST client, I'll show you here REST. So this is the REST client I installed in VS Code. That allows me to create these .http files that now allows me to send the request, which is marked here below. So now it's going to do a GET request to my local running function. So let's do that, and it gives back the 200 OK with the text welcome to Azure Functions. So the default template Azure function is working locally. That's cool. Perfect. Okay, I'm gonna stop running. I'm gonna disconnect here. Close this. Let's go back to the different files again, because I skimmed over it. I only showed you this class file, but there's more to see here. Since this is a .NET 6 isolated function app, there's also a program.cs, and the program.cs is responsible for creating a new host process, and which actually is responsible for running your functions. And so if you use .NET 6 isolated process, you have the Azure Functions runtime, which is running in its own process, and you have your functions runtime, your actual function. So that's a worker process running separately. So there are two processes running. If you don't do this isolated runtime, it means it's in process, then both the runtime and both your functions running in the same process. Another thing is useful to know is the host.json files that is used for, let's say, function app wide settings. So in this case, it contains some default logging information that it should use application insights and that you want to sample the settings. So the sampling is enabled, but we are excluding the requests from being sampled. So there's lots of stuff in the documentation, which is also, I think, in here, how you can add more configuration to this, and you can really override the default behavior to quite a big extent. The CS project file, well, if you're familiar with .NET development, that contains the definition of your .NET project. In this case, the target framework is .NET 6. We are using or targeting the latest Azure Functions version, and that's in V4. Yeah, we have some regular .NET output types and things like that. What is important to know is which references, which NuGet packages we are using. So in this case, we are using the Azure Functions worker, so that makes sure that we can run this in a separate, isolated process. So we have the worker, we have the worker SDK, so we can actually build against it. And all of the extensions that we use are part of different NuGet packages. So in this case, we are making HTTP triggered functions, so we're using extensions.http. Right, what else is useful to know? Yes, the local settings JSON. So this is also generated by the template, and this contains your application settings. So it's not configuration in a very detailed level, because the host.json is for let's say to override certain settings of how functions is working. But the local settings is more of a level of application settings. So this should contain connection strings if you want to connect to a database, or this should contain an API key if you want to connect to an external service. These things need to be in here. So if you want to use a new API key of some service, do it like this, API key. So this can be anything. So just like key value pairs. This is then the value of your API key. So you might notice that this file is called local settings JSON, and it's not included in Git. So this should never be part of your source control, because it could contain API keys or connection strings, which should remain secret. There are ways to actually publish your local settings to the cloud. So if you're using these API keys or connection strings, you can easily publish them to the cloud. Of course, you can also set up a complete CI/CD pipeline where you can do that. That's a bit out of the scope of today, though. But for now, it's important to know that this file exists. It should always mention what kind of runtime you're using. In this case, we are using the .NET isolated runtime, but we're not using any external services. So that's it. All right. Yeah, what I didn't show you yet is that a post is also working. But I think we understand that a post is also working. So let's now actually change the template. So we're going to do the next exercise 2, changing the template for get requests. So let's open up the file again that contains our function definition. So currently we can do both a get and a post, but let's say we remove this post. So now this function only accepts get requests, not post requests anymore. Let's say, for instance, we want to read something from a query string. So let's say we want to pass in a name, part of the query string, and we want to read that query string and use that name when we write the response back. So instead of welcome to Azure Functions, we do hello, and then we pass in the name that we got in the query string. So we need a way to read a value from a query string. But this HTTP request data, this type, this doesn't contain any method to read something from the query string. So we need to introduce something else. We are using a different namespace, system.web. So let's add that namespace here. And if we want to retrieve a query string from the request, You can use this code here. It's the HTTP utility, so that's part in the system.web namespace, and that has a method called parse query string, and then we are putting in the request and the URL and the query right there. So that returns us a collection, a name value collection, and we are extracting the value for the key named name. So that's the idea. I'm going to remove this logger step because it doesn't have any value here. So what we have now, we have a get function, and we are going to extract the name query string value. Then we have the response, but we're still going to change the response. We're going to change it into this. So you hello name. All right. So our function looks like this now. It should be good. Okay. So let's now run it again. So we press F5 to start everything. And while it's starting, I'll look up the HTTP file again, this one, and I'll make another entry here. So do another get, but now we can use a query string. All right, so our function app, our local function app is running. We can see that the trigger is still recognized, so that's good. So now let's call it, and note that we have a name key value pair here. And we get a 200K back, and it says hello Codementor. So that's cool. Our function is working, excellent. I'll keep it running for just a bit, because what happens when we leave this blank? If we do no value or no name at all, so let's make it completely blank. So what happens then? Then it still comes back with a 200K and just says hello, comma, and then nothing else. So I think this is not a nice behavior, right? I think the function should actually validate its input, and if the input is not valid, it should respond with a bad request, a HTTP 400. So that's what we're going to do next. Stopping the debugger, closing this here. So we're gonna change the function a bit. Another tip that I usually mention when writing functions in .NET is functions are always have a name, and that name must be unique inside the entire function app. But usually it's just a string like this, right? It's hello world HTTP trigger within quotes. But usually I don't like this dependency on strings. What I usually do is I use the name of the class. So in .NET you can then do on/off, and then do hello world HTTP trigger. And so the name of will just convert this type into a name, so the result is the same, but at least I don't have these magic strings everywhere. All right. So now let's check if the name is actually used, and if it's not used, we will return a bad request response. All right, so part of this stays the same, right? We still use the query string collection. We are going to extract the name, but here then there should be an if statement, and that's exactly what we're going to write here. I'm just going to type it out for now. So if string is null or empty one, so then we should send back the bad request response. So that I'm going to copy. All right. I should of course make sure that I find the response first, and then I can change it. Okay, so the response is still defined as normal. Then I check if the name is null or empty. If it is null or empty, I'll change the status code to bad request, and we write this string back. Please provide a value for the name query string parameter. So in the else, I can just do the regular stuff, because that is our success. statement. So this is just fine. We should make sure that the status code is then set to OK. So I'm going to remove this here because initially we created a response and we gave the status code in there, but we don't need to do that. We can just don't provide a HTTP result code in here. So now we're doing it in here. Lines. Okay, so now we have a function which is validating the input, and based on that, it will either give a bad request if the name is empty, or if the name is not empty, it will be okay. So now let's run this again, and let's get my test file. Starting up the local Azure functions runtime again. Okay, it is all running. Cool. So now let's first do this one where we do provide a name. So that should still return the 200. Okay. Yes, exactly. And now let's do this one, and that should now return 400. Yes, bad request because that's empty. Okay, perfect. So that's also working. Okay, let's stop the execution again. So far so good. Now let's change the function and focus on post request instead of get request. So what we're going to do to our function is we're going to put back that it also allows post request. That's this part. And let's change up a bit here what we're going to do in case of a get request or a post request, because we can actually check the request object if the method used is get or post. So we can change the logic. So what we're going to do here, because if it's a get request, then we want to execute this piece of code handling the query string. But if it's a post request, we don't want to do that because then we are looking for a name that's provided in the body of the request, not in the query string. Right. So what this piece of code does is it checks the method of the request. And if the method equals a get, then we start doing something with the query string and we set the name. Otherwise, we will extract the name from the request using this method, the read as a string async, and that reads it from the body. There are some red squigglies though, and that's never a good sign. So this is an asynchronous method, and we're using await here, and that's important because otherwise we don't have the right result. But if we use await in a function, that means our function needs to be asynchronous, and our function is not asynchronous at the moment, so we need to change it. So let's put here async, so this whole function is asynchronous. That means we also need to change the return type. Asynchronous functions will always return a task. Do it like this. Okay, so now there are no red squigglies anymore. That's good. So if the method is get, we use the query string. If the method is not get, so we're not even explicitly checking if it's a post, but since we are allowing either a get or a post, the other situation can be only a post. So then we read the name from the request body. Okay, so we made the function async, that all worked. Oh yeah, there are a couple of other async methods which were in here already before, but those weren't being awaited. So it's the best if we do await those as well. Okay, so the right string is now also awaited. Cool. So now we can test the function again. And we can test it with a get, but also now a post. So let's start running this one. And let's look up this file again. So we're also going to do a post to this URL. And this post that has a content type of plain, and it will have or as well. Right, so it's up and running. So let's first trigger the get, which uses the name as a query string to see if we didn't break the function. That still goes back to 200. Okay, perfect. And now let's test the post, and we put it in the request body. So now let's test this, and yes, this also works. Perfect. All right. So so far so good. By the way, I didn't mention this, but you should definitely also have a look at the terminal here, which does quite a bit of output when your Azure functions are running. And so it mentions first that the functions which are discovered. So that's important because sometimes maybe something is misconfigured or you made a typo somewhere, but it does build, but then your function is not discovered or you miss the function attribute, so it's not there. So it's always very useful to keep an eye on this terminal. But you'll also see that functions are executing. So it means it is running, but it's also logged when functions are done. So it's executed. So definitely keep an eye on this terminal when you're developing and testing your functions. All right, this is good. So our function now works with both get and both posts, and it does some input validation as well. So that's perfect. So now let's continue with handling post requests with some JSON data, because now we're just posting a string, plain text string. But I think in the majority of the cases, if you're dealing with HTTP, you probably are dealing with the JSON objects as well. So let's create a copy of our function, right? Because I mentioned before, like we are creating a function app, and currently it has one function, but it can support many functions. So let's just copy paste this and change the name here. This is exercise 5, so I'm going to call it Hello World HTTP Trigger 5. So I'm renaming the file now, but I still need to rename the class, right? Because otherwise I have two files which are having the same class definition and also the same function definition, and things are going to break them. So I'm also renaming the class, the constructor, and most importantly, the function name, since those need to be unique. All right, so I have the Hello World trigger and the Hello World trigger 5, and this one will be about handling requests with JSON data. All right. What we also need now is an object. At least it makes it nice to work with. So we are going to create a person record, which just has one property with the name string. Feel free to extend it yourself later on if you want to have a bit more complex things going on. So let's name this person.cs, and I'm going to copy this content in here. So it's a record type. So records are relatively new in .NET. Maybe you're just used to class definitions, but the record is a new .NET type, and it's used for data classes which are supposed to be immutable. So you create this or you read this, and you just keep it as it is. You're not changing it. And it only has a name property, and that's it. Okay, so let's go back to my function. So this is only handling, or this should be handling only post requests. So I'm going to delete get verb here, so it can't trigger. It also means we don't need this part either. So we can actually replace a large part with just this. So I will remove this because our method will only handle posts, and we're not doing anything with query strings. And we're also not reading as string because we are dealing with JSON data now. So I can replace this whole thing with this. So this is interesting. So on our request, there is a method called read from JSON async of type person. So this is the person type we just created. So that's this. So using this method, we can actually very easily read a typed object from our request. So it is JSON what we send in, but thanks to this function, we can immediately get a typed person back. So this person variable is of type person. So that's pretty cool. All right. So the response will be the same. We'll just be writing the name, but now, of course, we don't have a name, but we do have a person. So if we want to do some validation now, we can do person.name. And again, if you want to use the person name here, we do the same thing here. So person.name. All right, and this BadRequest, this should actually be different. I'm going to copy paste the exact message here because I'm just very lazy. All right. So the only thing is, so this person could still be null. So that's also not what we want. So we could actually make this a bit better. So if it's not null, no, we actually this is the other way. So if the person is null, or if the name attribute or parameter of person is null or empty, then we do the BadRequest. Otherwise, we do this. So we're 100% sure that person is not null and name is filled in. All right. Time to start this function up again. And I'll create another entry in our local test file. So we are going to do a post. Now, hello world HTTP trigger 5. So you see we have now two functions here in our function, the regular one and the number 5. So this should also be number 5. The content type should have application JSON. This one. Since we only have one property in our file, this is then name. All right. So this should do it. Let's run this. Ooh, we get a 404 not found. Okay, so something is not okay here. Let's see. Oh, I did some weird copy pasting. Look, localhost API, localhost API. So that obviously did not work. Let me copy paste it again. Make sure our endpoint is okay. This looks a lot better. And we now get back a 200 OK hello Codementor number 5. Okay, so that's also working. Excellent. I'll stop this again. So now we are at the final part of this exercise, changing for a custom route. So right now our output was always hello something. But what if we made this dynamic as well? So instead of saying hello, we could say hi or hola or anything else. So let's try that. And we're going to try that by adding a parameter to the route. So we're going to change the route. So we're going to put whatever we want to put here. The greeting we can put in the route. So I'm going to make a copy again of the initial hello world HTTP trigger. And let's do number 6, which is exercise 6. And again, that also means that I have to update the class name and the function name. That's now done. All right. The very important thing now. So we are now going to work with routes. In route, we have to specify in the HTTP trigger attribute. So we have to now add this. So we already have the first part. So I'm just going to copy paste the route part. So comma route. So we need to add this. All right. So now our route property of the HTTP trigger attribute contains this string. So this string then represents the new endpoint of this HTTP triggered function. And this again can be anything. So I'm just naming it exactly the same as the function name is, but you can write this to anything. The other thing that we've now added is an expression in the route, and it's called greeting, and it's of type alpha, meaning we can only type letters in there. The question mark means it's an optional part of the route. So we can either trigger this route just by providing this URL, or we can do a slash and then provide a greeting in there. But this part is optional. All right. So this greeting here, we want to use this greeting inside our function. But right now it only lives in the route and nowhere else. So if you also want to use this inside our function, we need to add this as a separate parameter, which is then named exactly as the part in the route. So this will be greeting. So now we have greeting here in the route, but also here as a separate parameter in our function. And now we can actually use it in our function body. This lesson contains a bit more information on how to use all these routes and expressions, and you can do some very advanced level stuff with it, like regular expressions and things like that. Pretty cool stuff. So now we can change the greeting part, because the rest actually remains the same. But when we do the write string async and do hello name, we are going to change that and also use the greeting in there. So it's this part. What we see here is we're using it in a again in a we're interpolating the variable here. So we are using greeting, but in case greeting is null, we have this this null coalescing operator here. So if the greeting is null, we fall back to hello. So if this is not filled in, we use hello. Otherwise, we use whatever this value contains. This should be it already. So let's start this here. And again, I'll add this to my list of functions to execute. Let's do this get first. So let's do this first. So let's first just add a name. CM. I'll be typing less and less the further we go. So let's first do this. So we're not providing the greeting. Oh, wait a minute. I should call function 6. Okay. So I'm calling function 6 with name is CM. It says get address e-info. Get it does. Oh, I have twice a get. I'm not very good at copy pasting today. All right, so let's do this again, and it gives back 200 OK with hello CM. So we didn't specify a greeting in the route, so that's why it falls back to hello. All right, but what if you do it like slash and then we do hi? Then trigger this. So now it says hi CM. Okay, so our greeting, our route expression is working. Excellent. Cool. All right. Well, and this is just an example of just one binding for Azure Functions, which can be already quite involved, right? I mean, you can do gets, you can do posts, and you can do puts and deletes and all of the other HTTP verbs as well. But you can also have control over the route and change some things in there, and use query strings and work with strings and with JSON data. So I think there's a lot here to discover and continue with. Let me now switch back to the slides. So this was building it, but the next part is actually running it. So I'll actually go straight back to VS Code, because I've got no slides for this section, because it's more interesting to see it right here. So this now lives locally. Hopefully you have added it to a Git repository, so it's actually safe in case your laptop burns down or something. So it should be in Git. But let's say you want to deploy this function now to the cloud. So there are lots of ways to do it, but I'll show you a very quick way, just using VS Code. Again, if you have the Azure Functions VS Code extension installed. Of course, when you are doing this, you need a subscription for Azure, right? So that's really clearly a requirement. So if you have a subscription to Azure and you have some of the extensions installed to work with Azure functions here in VS Code, you can click this Azure icon. And it has changed a bit recently, but there's this resources tab, and that allows you to explore your Azure subscriptions. Choosing this one here, sponsorship, and then you can go and look at different types of services you have in Azure, depending on the extensions you've installed. So I'm now looking into function apps, and it now lists all of my function apps which are running in the cloud. That's all fine, but I want to create a new one. So I'm going to right click here and create function app in Azure. That's what I want to do. So now we need to provide a globally unique name for the function app. So let's go with something called Codementor. So that already exists. I usually postfix my functions with -function app, and that doesn't exist. Perfect. So Codementor-FA is the name of my function app resource in Azure. All right. Which runtime are we going to use? Well, we are going to use the .NET 6 runtime, so that's correct. I will need to make a change a bit later because there are like two flavors of .NET 6. There's the in-process one and there's the isolated process one, but that option is not here, which is a bit of a miss. So we are going to choose .NET 6, but we need to do a small tweak afterwards. Where are we going to deploy it? Where's Europe is the closest to me, so I'll do that. You always have to choose either the closest to you if you're just developing it, or the closest where your users are. I do Where's Europe. All right, so right now you can see here it's creating the function app. So it's creating the Azure resources right now. Step 3 of 6, so it's getting there. And once it's done, you will see it appear in this list. So this thing is one test that I did a bit earlier, so that's not the one yet. So it's now creating a storage account. We didn't talk about that, but a function app in Azure depends on a storage account, because the storage account contains your function app files. Because if there's no use for your function app, there's no instances running of your function, but your code, your compiled code needs to live somewhere in the cloud. So that's stored inside a storage account, and then it's then deployed to a function app as soon as requests are coming in. All right, it's now on the latest step. It's creating the function app itself. And, pretty soon we should see a new function app appearing here. Once we have that, it means we have a function app resource in Azure, but it doesn't contain our code yet. So then there's still one step to do to actually deploy our code in there. And yeah, here it is. It's successfully deployed it. This is our function app here. But the functions in here this will contain nothing. It's still completely empty. One of the things I mentioned we should change before that is the functions worker runtime, because the functions worker runtime we have locally is .NET isolated. I'm just going to copy it. But this functions worker runtime, we can edit it right here. Oh, no. Edit setting. Am I doing this correctly? Oh, it was a different one. Yeah. So this is set to .NET and not .NET isolated. So I need to change that. So I'm copy pasting .NET isolated in here. So now the functions worker runtime is changing to .NET isolated. So now our function app in the cloud is now matching our one we have locally. Okay, so what I can do now is actually deploy to function app. So this deploys my local code to the function app. It's a very tiny checkbox, but it says, okay, do you want to deploy to this function app? Yes, go. So now it's deploying. It's publishing my functions to the cloud. Right, and now it should be there. It's refreshing now. should be able to see our function running live. Still deploying.
Hey, Mark. I think I don't know how long that's going to take, but we already have one question, and I want to take
let's
it all the way through
let's
this.
go to the QA. Yeah, that's fine. Okay, this completed, but
Oh,
I think people believe that is there, so let's not call it. I think it'd be because it's also we crossed the 1 hour mark already, so let's do some Q&A now. I think it's totally fine. Yeah.
awesome. Well, thank you so much, Mark, for the great theory and the demo. I think I always like it when talk about a theory, but then there's like the hands-on portion. I think that's really important,
Exactly.
and
Yeah,
people can watch it later as well. Yeah, so we got a question from Sadio, and I apologize if I pronounce your name wrong. But they ask, between Azure Functions and REST APIs, what would you use if tasked with implementing CRUD operations to manage, for example, flights?
Yeah, you can use both serverless, or you could go for a complete web app in Azure. That doesn't matter so much. I think you should definitely look into the workload question, right? So is this expected to be, let's say, continuously used, so you have a kind of a constant workload, or do you expect a spiky workload? So if you do expect a spiky workload, then I would say choose the serverless direction. If you're worried about, for instance, cold starts, so often that's often heard complaints, right? So if you go serverless, you might have some cold starts. So when a visitor then want to action on some kind of functionality, you have to sometimes wait. But there are ways around that, right? So there's different tiers in Azure. So you could go, for instance, for a premium tier, which always have one instance warmed up for you and up and running. So you don't have the cold start issue, for instance. But yeah, it really depends on the workload. You can definitely use both.
Awesome. Well, thanks for the answer. Yeah, anybody else got questions? I know some of you had to leave earlier, but you still have time, have questions. I believe we have time to take one or two more.
I'll just have like 3 more slides, so at least I can show those before we have maybe some more questions. So sure. Right now I only worked with HTTP triggers and no actually bindings yet. If you want to go to the next level and also explore what you can do with bindings and use blob bindings or table bindings or also DB bindings, I can definitely recommend you this repository. I'm actually giving another talk for Serverless Days New York in 2 days, which is about the persistence in the service applications. So there's a ton of information here in this repo. Last but not least, I created a game recently that's running on serverless, using HTTP triggers. It's also using one of the more advanced topics that is using durable entity. So it's actually a stateful function because it's storing some state. So it's like a tiny multiplayer game, turn-based with some real-time components. So feel free to, of course, play this, but I think it's also very interesting for you to actually click on this tiny GitHub links and actually look at the code, how it is created.
That looks cool. Wow. Okay. Awesome. Anybody else have questions before we wrap up? Yeah, and Mark is putting all his
yeah, if you want to contact me later, I'm on Twitter. If you want to go to GitHub, there are lots of repos there. If you have any questions about Azure Functions University, or maybe you want to help me out with creating some lessons for Azure Functions University, also more than welcome. So yeah, feel free to connect in any way.
Awesome. Well, I'm gonna drop a few links in the chat as well. So yeah, you got Mark's Twitter, but then you put YouTube and GitHub on there as well if you want to follow him there. Yeah, I just want to make some quick announcements that we have more events coming up. We're going pretty strong for the next couple weeks, so make sure you check that out. I'll put this slide up after we end and just show some information and keep this open for a few minutes for those who want to get it. But before officially ending, Mark, I just want to thank you again for taking the time to do this and show us all these cool tricks. Yeah, do you have any I guess final remarks or encouragement for for our attendees today?
Well, if you're learning something new, it can be exhausting and tiring. I find it always helps if you can find someone else who wants to learn the same thing, right? So if possible, don't try learning something on your own, but find someone else or maybe a whole group of other people to learn together and share some experiences. That's always helpful.